Hi everyone! Today I want to show you a new project I started and it has something to do with this reef tank. So I'm really a fan of reef tanks and corals, and among corals the ones I like the most are stony corals. Now the thing is with those stony corals, you really have to keep your water parameters in check. And there's one water parameter which is alkalinity or carbon hardness that has to be tightly controlled, because especially stony corals require this alkalinity. There has to be enough there, and also it has to be very stable. So ideally one measures this every day or every second day. But the thing is, I'm quite lazy. I mostly only do it once a week, which often is not enough. And I was always dreaming of that one could automate this. And there are commercial products available. However, they are very expensive. I think the cheapest one is around 600 euros. So it's quite a lot. And anyways, I needed a new project. So I thought I'd just build one myself. And it turned out that it's just around 100 euros in parts. Most of the things I actually already had at home. And it was good fun to just build this. And in this video I will show you the first prototype I built and what are the thoughts behind it. Alkalinity is a measure for bicarbonate. So bicarbonate is basically HC3 minus, and the corals use this to incorporate carbonate and calcium into their skeletons. So here we have the CO3 minus plus H plus here. And alkalinity is used as a proxy basically to measure bicarbonate. This we can make use of. We can add acid to a water sample and then measure how much acid we need to reach a pH of 4.5. And that's actually the principle also of all these titration test kits to measure alkalinity, that you titrate an acid to your water sample and the indicator liquid tells you when you cross this threshold of 4.5. And this is what we want to make use of. So how do we do that? Well, the idea is that we take automatically a sample from the aquarium here, take the sample with some kind of pump and we put it into this cylinder. So we have here a water sample and we know the volume of this water sample. And to this water sample we add an acid, drop by drop. The smaller the volume we add at once, the better, because then we have a higher accuracy. And to know when we reach this threshold of 4.5 the pH, we have a pH probe in there that measures the pH, and once this threshold is crossed, it stops, and then we have a volume of acid that was required. And with this we can then calculate alkalinity, and we can do this with the following formula. Our alkalinity measured in dKH equals in the end the volume of the acid, and in this case we will use 0.1 normal acid. I will use HCl because then if you add it, it's just chloride and there's nothing to worry about for the inhabitants of the reef tank, because the plan is to pump the sample then after it was tested back into the reef tank. So here we have the acid, and this volume we simply divide by our sample volume that we know, and then multiply the whole thing by 280. And this gives us our dKH. Simple as that. So the only thing we need here is we have to exactly know how much acid we added and exactly what is our sample volume. So here we have the device that does all the measurements and then sends it on. We start out with here, it takes the sample from the water from the aquarium. So with this peristaltic pump that I 3D printed, it's a redesign of a Thingiverse peristaltic pump actually. It gets pumped into this beaker. And this peristaltic pump is driven by a stepper motor, so I can pump accurate amounts or always the same amounts of water sample into this beaker. Then in this beaker we have here a pH probe and here another peristaltic pump with a stepper motor that pumps the acid into this beaker 2 microliters at a time, so that we then decrease the pH until we reach the threshold. In this beaker we also have this small magnetic stirrer. It is driven by a computer fan with a small magnet glued on it, and you can see this here. Here's just a computer fan with here the magnet glued on, and then this drives the magnetic stirrer. Now this whole thing has to be controlled somehow, and I do this with an Arduino that basically drives the stepper motors via those H-bridge drivers that I built here. And also it controls the magnetic stirrer just via a tip 120. And it also measures the pH via the probe. So there's this board here to which the probe is connected, and this is then connected to the Arduino, and it gets the measurements from the pH probe. So the process this Arduino controls is to at first take the sample. So it takes the sample in here. The peristaltic pump into the beaker. Then it starts the magnetic stirrer, and then step by step it adds the acid. 2 microliters at a time. You see those small drops with this stepper motor peristaltic pump. And then the pH probe here measures the pH constantly. Until it reaches 4.5. And in the end, the only thing it does, it gives the amounts of steps to a Raspberry Pi via the serial interface. And this Raspberry Pi then calculates the dKH based on the sample volume and the amount of steps that were required to reach this pH of 4.5. I made a small graphical user interface, as you can see here. It's also just a prototype to be able to measure the KH as well as pH and also the sample volume and so on. What this also does is it sends the values then per email to my phone, so I know it, and it also writes it in a file so that later on I can plot it. Once it's done, it just takes the sample and discards it just back into the aquarium, and there's nothing to worry about. It's just a low pH, but it doesn't really affect the pH of the aquarium, and since it's HCl, it's also not a problem for the inhabitants of the reef tank. So it actually then washes the whole thing again twice, so that next time when it takes the sample, everything is fresh. I also compared the dKH measurements with this HANA checker. I think it's one of the best devices to measure dKH manually. So the first time I used this to correct this automatic dKH measurements that it shows the same as here. The reason is I don't exactly know if my HCl is really a 0.1 normal. I just diluted it by hand, so it might not be very accurate. But it doesn't matter. It's just about that it always measures the same. And this, it does quite well. So I compare it, I think 5 times so far, and they were always within 0.1 within each other. And that's enough for me. So this allows me to test the dKH every day, and if necessary, I can then adapt the dosing of my alkalinity solution. Also, if I'm on holidays, I can do that because I get the email, and I can also access this Raspberry Pi remotely, and then adapt the dosing pump accordingly so that the dKH levels are stable. And this also gives me peace of mind when I'm on holidays, that the tank is not crashing and my corals are not dying. So this is the first prototype that measures automatically the dKH. If you are interested, I can explain a little bit more and also show you exactly how you can build this. So if there's enough interest, just let me know. Until then, thanks for watching and see you next time.